Last weekend, my hometown of Boone, North Carolina was devastated by Hurricane Helene. Thankfully, all of my friends and family are accounted for and okay, but it will take months, if not years, for these communities in Western North Carolina to recover. I don't know about you, but when I think about how these natural disasters are only getting worse as climate change gets worse, I get depressed. And what really gives me hope is thinking and learning about all of the technologies we have that are improving forecasting models and saving as many lives as possible. So in today's video, we're gonna talk about how satellites orbiting high above Earth are helping us predict, track, and respond to hurricanes. As you'll see, satellites are an invaluable tool in saving lives and properties, and the technology is only getting better and better. So to start, let's go all the way back to the late 1800s. It's hard to imagine now, but less than 150 years ago, coastal towns had almost no warning when a hurricane was going to strike. The earliest hurricane warning was issued in 1873 using basic barometer readings and even ship logs to piece together where the hurricane might go. The warnings were issued via telegrams, and they often came way too late, like the Galveston hurricane of 1900, which unfortunately was the deadliest disaster in US history, taking 8,000 lives simply because we didn't have a reliable way to track hurricanes. By the 1940s, the situation started to change. Advancements in World War II aircraft technology led to the first hurricane hunters. You know, those people who fly planes directly into a hurricane to measure things like wind speed and pressure. I could never do that. But this was the first time that we could truly see inside of a hurricane. It wasn't until the arrival of digital computing in the 1950s that we could really start making sense of all of this data that these hurricane hunters and other things were collecting. And that paved the way for the hurricane modeling that we have today. But the real game changer came with the launch of the GO satellite in the 1970s. For the first time, we could continuously monitor the entire Atlantic Ocean and watch as hurricanes formed and intensified over thousands of miles. These first satellites only viewed Earth about 10% of the time, but they paved the way for more advanced technologies and forecasting models with newer 21st century satellites like the GOES R series. These new satellites are equipped with extremely high-resolution cameras that can see the entire Western Hemisphere and take photos of it up to every 30 seconds. They can even see through clouds and monitor how much rain is falling, as well as lightning inside the storm. To learn more about the role of space technologies in hurricane forecasting, I had the opportunity to speak with Dr. Karen St. Germain. She is the director of NASA's Earth Science Division.
Most people don't realize how many space assets NASA has looking back at our home planet. We study Earth more than we study any other planet. We have about 24 missions or so. These can be sensors on the International Space Station, or they can be free-flying instruments, and they are looking at the whole Earth system, so land, ice, the oceans, the atmosphere, precipitation, vegetation.
Another unique thing about satellites is that they can see changes in near real time. And when combined with data from ground and air-based sensors, they help provide much more reliable predictive models.
You can't see the whole Earth any other way than from space, but to go from seeing to understanding, and then from understanding to prediction and projection is really the key.
So how do we go from seeing to prediction? Well, satellites like GOES continuously stare at our Earth, looking for the ingredients of a hurricane forming, like warming sea surface temperatures and changing wind patterns and more atmospheric moisture. To learn more about the GOES satellites in particular and how they monitor storm development, I talked with Jagdeep Shergill, who's the program director for Geo Weather programs at the company who builds the GOES R satellites, Lockheed Martin.
They are our nation's most advanced set of weather observation satellites. So they live in a geostationary orbit, which means they're always looking at the same spot on Earth and having that continual observation. The two main instruments that are looking at the Earth are the Advanced Baseline Imager and the Geostationary Lightning Mapper.
The ABI captures high-resolution images across 16 different spectral bands, aka different parts of the electromagnetic spectrum. The data from ABI helps meteorologists track storm development minute by minute. And the photos you see on forecasts actually come from ABI too. Then there's the GLM, which is actually a pretty new technology. It first launched in 2016.
The GLM is the first geostationary lightning mapper ever flown. And what it's doing is it's measuring the lightning strikes, not just the cloud to ground lightning strikes, but also the cloud to cloud lightning strikes. What we're realizing after we got the first GLM OnGo 16 up into space, the intensity of lightning strikes is a predictive factor on how intense the storm is going to get and the intensity rate at which it will progress.
But GOES isn't the only set of satellites monitoring hurricanes. There are tons of other government and commercial satellites orbiting in various different places above Earth, and they're all like little puzzle pieces filling in the gaps that GOES can't do alone. Now, once a storm forms, satellites are essential for tracking its path, estimating when it's going to make landfall, and predicting its damage. For example, one of the first things that agencies like NOAA do after a hurricane is create detailed flood maps using satellite imagery.
With our newer instruments, we're progressing from being able to tell them where there's water to how much is there. We can do things like map power outages. We can tell them how much rain fell. And all of this kind of information helps emergency responders position relief. It helps them plan evacuation routes and all those kinds of things.
NASA also just stood up what's called the Disaster Relief Coordination System, which is streamlining access to data for first responders everywhere. So that's where we are today. But as many of you, including myself, know, we need even better predictive capabilities to help save more lives and prevent as much damage as possible. So let's look at a few of the advancements people are already working on today.
The next generation of weather observation satellites is going to be called GeoXO, so Geostationary Extended Observations. So extended because we'll be adding a few new instrument types and doing more specific science targeting to oceans and the atmosphere as well.
And then there's this really cool mission called INCUS, which is set to launch in 2027.
It's 3 CubeSats. They each have a radar on them. They're flying 30 seconds one behind the other.
INCUS is going to help us get a clearer picture of why, when, and where some of these tropical convective storms form, and why only some of them produce extreme weather.
So they each get a snapshot, and then when you take those snapshots together, you can see how a mass of wet air has moved up. Why is that important? Well, all that moisture, what goes up is going to come down.
And of course, AI is going to be a huge game changer. With all this data coming in, AI can help us sift through it faster, and it can help us make connections that human analysts might not see.
AI and ML still really rely on observations and data. It's just that they give us new tools and new ways of extracting understanding and information from the data.
This means faster, more accurate forecasts, even down to smaller areas that traditional models might struggle with. And leading the charge in all of these advancements is NASA's Earth Science Technology Office.
The Earth Science Technology Office is dedicated to advancing technologies. Those technologies that we need to make our sensing capability better, whether that's more accurate, higher spatial resolution, more rapid revisit. Maybe it's to make it more affordable so that we can fly more of them.
All of these new technologies and so many more that I just don't have the time to cover here are helping us understand how hurricanes form, evolve, and impact our planet, which is going to help us save more and more lives and property and respond to hurricanes before they hit. From the early days of basic hurricane warning systems via telegrams to now advanced satellites and AI modeling, we've come a long way. But no matter how advanced we get, the goal is always the same: save more lives and give these communities a fighting chance against these powerful storms.